Thanks for having me, Michael. This will be about AI assistants, and what I want to do in this talk together with you is building something like this here, and sidecar. So this is the so-called sidecar pattern, you know. Nowadays there are very, very complicated pattern names for simple things like a chat window that can be displayed or hidden. However, this is far more than just a chat, because you can hide it and use the application in a traditional way if you don't need it. But if you need it, because you are stuck somehow, or because you want to automate something, you don't want to click 50 times, but you want to tell the assistant what to do with one sentence, then you can activate it. It's also more than a chat, because it can display components on demand. That means it can select a component from a catalog of components. They are interactive, and as we will see, it can remote control your application. It can jump to this or that route. It can pre-fill this or that form. So let's have a look to this example. So here we have my infamous flight search application, and let's assume we are stuck. We don't find the correct menu item, so we are activating the assistant, and then I'm asking, do I already, or did I already book my flight to France, country of love? And then it's doing something in the back, and it says, yeah, there are several flights, and at least one of them goes to Paris. So it's this one here. So it's an interactive card. It found out, well, this is a flight, so let's display it with a card like this. And now I can say, let's check in for it. Okay, so another question. Did I already book for Spain? Spanien, Spain. And then it's thinking, it's performing some tasks. No, you did not book. Okay, so let's search for flights from the metropolis of Graz to Madrid. And then, yeah, look here. So it's jumping to the right route, it's filling out the search form, it's pressing search for me, and I'm seeing my results. So I say, which of those are delayed? And there should be one delayed flight, this one here. I select the first one that is in time. And then this one should be selected, or in there I can also select and deselect my stuff. Okay, so this is the principal idea. So it looks like a chat, but it's more, it can remote control the entire application. So how does this look like architectural-wise? Well, the general flow is there is some kind of user intent, something the user wants to achieve. And this intent can be explicit or implicit. When it comes to explicit intents, the easiest way to get this intent is a chat window where the user types in what they want. But there are also other kinds of explicit intents, like uploading a document, like uploading an invoice so that the system can check whether this invoice is justified, whether this invoice should be paid and when it should be paid. Or if we can risk it or not pay it, and then we can see something like this. So those are two examples for explicit intents. There is in theory also something like an implicit intent, and if you are old enough, you have already seen this in the 90s. Who knows Clippy, Karl Klammer? Some of you, yeah. So perhaps you know Clippy, this strange guy who appeared immediately and asked me, well, Manfred, it looks like you want to write a letter. Do you need some help? So this would be an implicit intent. Because of the user interaction, it's finding out, well, the user is trying to do this or that. For instance, when I'm searching for the numbers of Jan and Feb and March, Clippy could ask me if I want to have the report for the entire year, something like this. Okay, but nevertheless, there is some intent. And then this intent is sent over to an agent. And this agent is just a little tiny piece of software that is communicating to an LLM and that is executing tools. For instance, it can tell the LLM, hey, if you need a bit more information, ask me to execute this tool, like the tool that is loading the booked flights, or the tool that is loading flights from Graz to Madrid, or the tool that is routing over to this or that check-in page. And then the tool will do it and report back via the agent the result to the LLM. And then one more time, the LLM, like the Duracell Rabbit, the Duracell Bunny, can proceed its work. And so we can go back and forth between the LLM and further tools that help us to do what we need to do in order to fulfill the user intent. At the end of this, oh, by the way, those tools can delegate to the store, to an EnsureX store, for instance, to forms or services. And I think in this case, state management even becomes more important, because state management, your store, is something like a headless version of your application. It can do everything your application can do without a user interface. So it's the perfect entry point for something that can be automated by a tool. Okay, so when we are done, at the end, the LLM emits some, let's say, JSON, and this JSON tells the agent that we should display this or that component with an answer. Could be just a textual component or a component like, like my flight form we have seen before. There is even another way to display a component. The agent could do a final tool call. A final tool call that is also activating a component here or there. Depending on the LLM you are using, you're going this or that way. Some LLMs cannot answer with structured data when you have tool calling activated. Gemini 2.5, for instance. In those cases, you just stick with tool calls, you do just tool calls, and the final tool call will tell the system which components to display. Okay, now let's try this out in practice. And for this, I want play the agent. Now, let's assume I'm the agent and I'm getting messages like the ones I have prepared here. By the way, those messages are on the level of GPT-3. So, it's like 2023, 2024. So it's Middle Ages, but nevertheless, this is a good way to explain this on this level. After that, I will tell you what changed in between. It's not that much from a conceptual perspective. And using this old style prompting, we can quickly understand what's going on there. So this is what you call the system prompt. The system prompt is a very strong prompt. It tells the agent and also the LLM how to behave in general. It sets the stage. And usually you start with something like this. You are a customer service agent working for a small flight agency and helping customers with their flight bookings. And to make it a bit more fun, who is speaking German? That's enough. Let's also say, and you speak a lot like Edmund Mundl Sackbauer. Okay, so let's go on with the serious stuff. Answer the following questions, blah, blah, blah. And now the important part comes. If you need additional information, call one of those tools. And then I'm describing some tools it can call. It can ask about so that it gets more context, like the booked flights of the user, or finding some additional flights, or showing a flight. And then there is another important thing. Only answer in a structured way using JSON, and here we have some examples. If it is possible, not only answer with text, but also with some tools. By the way, showing examples has also been proven to improve the quality of the results you get. It's not that important anymore nowadays with modern LLMs, but especially when you have a weak LLM and an LLM where you want to save a bit money, so you use it in a very weak mode, then this is really gold. And still, even though the traditional LLMs are quite powerful nowadays, also this helps a bit with the more powerful ones. We have some rules, what to do and what not to do. For instance, it's forbidden to display flights from a competitor because those flights are reachable via the internet. So the LLM might come to the conclusion, well, let's just look out to the web and display some flights from a competitor. Yeah. So this is the system prompt. This is always in place. The application takes care of it. And then the user is coming and saying, well, first question, have I already booked a flight to France? So now I, as the agent, take both and copy it into my LLM. Of course, the application is doing it via an API that has a lot of possibilities for fine-tuning, not fine-tuning in the LLM sense, but controlling what you want to have. And here, the model is answering, okay, in order to answer this question, I want to ask you, my nice agent, to execute this tool. Get booked flights. Okay. So now let's say I, as the agent, reads this, because it's JSON, I can interpret it, and then, and then I will answer with the results, all the flights the current user has booked. And then it goes on, okay, do reactions, yeah. This would not be the case when we went via the API, but now we see an answer that is very Edmund Sackbauer-like, Oida, schau mal, und so weiter. And then here we see the flight we have already booked that goes to Paris. Okay, so next question, have I already booked a flight to Madrid? By the way, this is a bit risky because sometimes it might screw up, you know, those LLMs like human beings are not that deterministic, but in this case it looks quite nice. Also a Mundl-like answer. And then one more time, show me flights from the metropolis of Graz to Madrid. And yeah, another tool call, including parameters. So the agent would now pass this and execute the tool and delegate it back to the LLM. So at the end of the day, when we talk about agents, at the core, it's not more difficult as this. At the core. Of course, there are a lot of stuff around it. You need to improve your prompting, you need to improve your tooling, you need to test it thoroughly. But at the core, it's about tool calling and prompting. Sometimes structured output. Okay. So now let's implement this game with Angular, and for this I'm using the framework Hashbrown. Hashbrown is open source and it has been tailored to work nicely with both React and Angular. It really feels natural in the Angular world. For instance, you use a resource, a Hashbrown resource in the Angular world. So it really feels like what you are doing all the time with Angular. And besides this, I'm also using Hashbrown because the people behind it are very known in the community. They are very known. One of them is part of the NGRX team. So they are known as someone who are capable of producing high quality open source stuff. And as you see here, we can use it to access a lot of different LLMs out of the box, and it's not that difficult to write an adapter to further LLMs. So the general flow here is that we have Hashbrown in the front end and a bit of Hashbrown also in the backend. This backend is just a tiny layer. With Hashbrown, you do most of the stuff in the front end, but you need a little tiny layer in the backend that is hiding your API key. Usually, you do not want to ship your API key with your client application, because then everyone can use it, everyone can do crazy stuff with your license. So better not do it. That's why this little tiny layer. To initialize hash brown, and also this shows how idiomatic it feels in the world of Angular, we can provide it in our application config. Like the HTTP client in the former days, like the router and so on, provide XYZ. This flag here is interesting, emulate structured output. I set it to true to be capable of also working with Gemini 2.5. Because when it comes to Gemini 2.5, we cannot get structured output when there is tool calling activated. So we need to go the green path here. The final call needs to be a tool call that is getting the structured output and a tool that is displaying this or that component. When it comes to OpenAI, then it's more flexible. OpenAI can mix and match structured outputs with descriptions of components and tool calls. And then we get this resource. It's an UI chat resource, one of several resources that is shipped together with hash brown. Perhaps the most powerful one. This UI chat resource can work with tools. You see it here. But it can also work with components that are displayed on demand in the middle of your chat or somewhere else. You just need to register it. Here you pass in the model you want to go with, and here you pass in the system prompt. And of course, now you are quite critical. Now you are saying, well, if we are passing in the system prompt, what's going on? Okay. If we are passing in the system prompt on the client side, someone can misuse this, replace it with their own system prompt to do a lot of crazy stuff with our license, with our money. And yeah, you are right, and I'm really happy that you are that critical. You are completely right. And the thing is, while we can set this on the client side, it's sanitized on the server side. So on the server side, you can read this. You can say, oh, you do not get GPT-5. It's too expensive for you. You get GPT-2 something because I don't like you that much. And you get the newest one, GPT-5, because you are one of my favorite friends. Something like this, you know. Very Austrian. No, please don't cite me. And on the other side, we could say, well, you can send me a system prompt, but I'm taking out this, like that we should communicate with you like the Terminator or like Edmund Sackbauer. Here, so sanitizing is not that bad here. On the other side, it's also a good idea to tell the user that they can change this a little tiny bit to adapt it to their needs. When we have this resource, we can read all the data we have received and displayed in the chat, our messages, but also the messages from the LLM. It's just an array exposed by the resources value. And besides this, we get some extra methods like send message, where we can send up our question. Or we can iterate through the messages of the value and display those messages. And sometimes when those messages represent a component with some inputs and so on, then we can render it with this helper component, HB like hash brown render message. So let's have a look at this. For this, here I have already the service that is registering my chat resource. I'm switching out the chat resource in a service so that I can have different chat resources for different routes. I don't want to have this big chat resource containing everything and affecting a lot of parts and domains of my application. Instead, I have here one chat resource per domain, perhaps per subdomain or feature. And as you see here, I'm setting it up with UI chat resource. I'm defining a model like GPT-5 and a system prompt lot of text. You are, that's your voice, those are the rules, here are some examples, and so on. And then tools. And the funny thing about tools is they are easier than you might expect. A tool is basically just a function with metadata. Just a function with metadata. So let's have a look here. Get booked flights. Create tool. We have some metadata, a name and a description, when to use it and some rules for using it. And then we have some lines of code here. Injecting a store and triggering some methods in the store, returning some values. So one more time, this shows that state management even becomes more important nowadays because a store is a headless version of our application. Okay, so let's have a look into a bit more complicated tool, find flights. So here we have the same, a description, a name, and then look here, a scheme. It's something like a SOT scheme, something like this. And it describes the parameter we can pass to our tool, or the LLM can pass to the tool. So basically it's about getting an object with properties from and to, both are strings, and here is some description. And so the LLM knows how to call this feature. Here we have the handler. One more time, we are doing something with the store, we are updating a search filter, and then we are navigating to the right route. And that's it. And when it comes to components, it's even the same. Here I have a flight widget, which is just a component, an ordinary Angular component. I don't want to burden you with details, but if you look here, we have two inputs, flight and status. Flight, of course, the flight we want to display, and status, is it a booked flight or another flight? When it comes to this, we need this to decide whether to display a check-in button or a booking button. And here is the metadata, expose component. This is the Angular component with an internal name, with a description. And here we are describing the inputs so that HashBrown can bind some data that comes out of the LLM to this very component here. The flight input is described by the flight schema that has ID, from, due, date, delay, with some descriptions. And status is described here in line. It's an enumeration which can have this or that value. And that's it. So what HashBrown now is doing is, it takes all this metadata, it brings it into a shape that is readable for the LLM, and then it sends it over to the LLM. And so the LLM can decide when to call a tool, and how to call the tool, with which parameters, when to display a component, and how to display a component with which parameters. So basically, that's it at the end of the day. Perhaps let's do something funny. Let's trace the messages we get here from HashBrown. For this, I'm activating my assistant one more time, and I'm asking the same question. Did I already book for Paris? Yes, here it is. Thank you. And then let's have a look to the console. Here I'm tracing all of the messages that are sent back and forth via HashBrown. So let's copy out this guy here. Let's go in there. It's JSON with JSON with JSON. That means something like a Matroshka puppet for developers. And now let's get rid of those escape sequences. And let's format it. And here we go. So here you see what HashBrown was sending over. it was choosing for a model with a system prompt. And here we have the first message. The user was asking, did I already book for Paris? And then the LLM said, well, yes, I don't know. But to answer this, please call this function here. Get booked flights with no parameters. If we had parameters, then we could mention them here. Then the agent is executing this tool, because the agent is really good at reading JSON. And then it sends back these tool results. It says, hey, I'm done. Here's the result. And then one more time, the assistant is answering with structured content, structured output, that says, hey, agent, please display some component, display a message widget with this text here. Yes, you have already booked. Yada, yada, yada. And then it says, please also display a flight widget with those properties, binds them to the respective inputs. Flight with an ID and from and to and so on. And that's it, basically. So I really hope I could demystify all this buzz about agentic stuff here. Of course, it's becoming a bit more complicated if you start adding additional stuff around the model. If you want to make it a bit more deterministic, then you need to do a bit more work. Another use case I want to slightly display is this here. Natural language query. I'm asking the system a question in a natural language. And I also ask it to compute the result in a form we can display with a chart or perhaps with a table. And perhaps you are saying now, yeah, Manfred, we already know we can do this with everything you've told us before, because you are asking for flights from Graz to Hamburg. So this is a tool call, isn't it? And then we are asking to calculate some percentages. This is something the LLM can do. And then we are displaying a component like, you know, here our bar chart. This is structured output. So in theory, we already know everything we need for this. However, there is one little tiny aspect we need to consider. Namely, LLMs are not good at math. They really suck at math. Because to use a metaphor, of course, each and every metaphor has its limitations, but a very cheeky metaphor here is an LLM is a parrot that is good in statistics. A parrot that knows how to answer because he has seen a lot of other similar answers. And this parrot cannot do math. If the parrot knows, it's also very simplified but in general, it's that way. If a parrot knows that 1 and 1 is 2, then he knows it because he has seen it often enough. Of course, you can improve those LLMs to do a bit more math, to have internal tools, but in general, they are really not good at this, especially when it comes to a bit more than just adding up numbers, like calculating a ratio or other formulas. So what we need for this is the same architecture as before, but now the LLM is generating JavaScript code, because this is something the LLM is really good at, telling you what to do. We all know such people. Usually they are not that beloved, not that sympathetic, those people that always know how we should do something, but never do it by themselves. But here it's really a benefit. The LLM knows how to do it, it knows how to describe it, it's really good at this. So it gives us JavaScript code. And then, of course, we need to execute it. And of course, we cannot execute it directly in our application. This would be an issue towards security. So we need to execute it in an isolated sandbox. And Hash Brown comes with such a sandbox. Just a little tiny JavaScript runtime that can only execute JavaScript and selected functions I'm passing in. Only selected functions. This is everything the sandbox can do. Functions like loading numbers about this or that flights. And at the end, the last function we are calling here will tell the component, the bar chart, what to display. So it's more or less the same. The only difference is we only have one tool, the runtime, and the runtime can delegate to further tools to runtime functions that look a lot like ordinary tools. They have an input and an output. So let's have a look at this, because this is always funny, and it's finally something where we don't need a chat. So let's go with example 2. I'm a lazy typer. I'm asking about delayed flights and flights that are in time. And then I can also say, when I jump to the end, sort by airport, give me the percentage, and then we should see the percentage of flights that are delayed compared to the percentage of flights that are in time. So let's compare this. When it comes to Graz Hamburg, 85% are in time and 14% are delayed, so should add up to 100%, give or take. 75, that's easy, and 25 should also somehow add up to 100%. So yeah, it looks like the numbers are not that bad. Natural language query, and another good example for something where we have an explicit intent but not a chat. So if you like this presentation, then you might also like my new book. I'm working on it now already the entire quarter. I started with it shortly after Christmas, and it will be published very, very soon. I just need to work in the feedback I got from a lot of smart community members. We have 400 pages, and it's PDF and EPUB for your ebook reader and so on. And there will be updates because everything is changing that fast, so there will be updates. And Q1 is my deadline, so I guess I have 20 days for it. But yeah, I'm really confident because I just need to work in the feedback I got, and then we are good to go. There is a waiting list, and if you subscribe to it, you get an early bird discount. It's angularbook.com. So the thing is, people who know me know I'm not exactly a person with fast movements. This is not my style. But when I saw that this domain is available, I needed to go to hospital afterwards because, my muscles were destroyed after that. But yeah, that's now my domain. Okay, so subscribe to it. Let me come to a conclusion. What did we see today? Well, we have seen today at the end of the day, all this agentic stuff at the core is about tool calling, and it's about structured output. It's sometimes about providing good examples to help the LLM a bit. And LLMs are really bad at mathematics, so we go with code generation and then execution in a sandbox. So that's it. I have already uploaded my material to my blog. You find here the slides and the hash brown example, and follow me on LinkedIn and Facebook and so on to stay in contact. Thank you.
Thanks a lot, and now we are ready for a lot of questions. 1, 2, 3.
How is it possible to prevent the user from inputting something that overrides the limitations of the prompt and not giving away all tools or what the bot is capable of?
Yeah, so the question was, how can we prevent the user from typing in something that he should not do, to use the LLM in a way he should not use, or perhaps even to override the system prompt? So there are several answers to this question. One answer is always send over the system prompt separately. don't give the user the possibility to directly set the system prompt. Sanitize it on the server side. The good thing is, even when the user starts chatting something bad afterwards, the system prompt really has a high meaning for the model. So if we look here, because of this, the system prompt even has here a different field. It's not one of the ordinary messages. It's something different, and the LLM will respect this. But this is not, it is just one side of the coin. There are also other sides of the coin. Another possibility would be to check up front if the message is an allowed message. You could use another LLM for this on the server side, which is funny because now we are using LLMs to check whether something should go to the real LLM. Yeah, so at the end of the day, we need some guardrails. We can do the same when the answers come back to the client. Usually, most people at least believe this, it is not good for business to insult your customers. So perhaps we should check the answer from the LLM with another LLM or LLM call and to sanitize this. By the way, this is also something ChatGPT is doing. When I'm asking a question, sometimes I see it's working and then says, no, I cannot tell you because this is against the rules. It's such a sensitive topic, so we cannot talk about this.
So did you test your flight simulator or thing regarding this issue with your implementation?
This one not, because it's just an example, but if you do it for production, then you need to do some testing, some automated tests for this, where you try to prompt different things over to the LLM time and again, and then you will see how often you get something back you should not gotten back. Yeah.
Sorry, just a follow-up question with regards to that. You say the system could block with regards to prompt injection.
Yeah.
Is that what you say?
Well, if you have an explicit system prompt, not just an ordinary first message, an explicit system prompt, this really helps a lot. Not 100%, but it really helps a lot because the LLM takes a lot of emphasis on this. And besides this, pre-filtering, post-filtering, when it is structured output, it's a bit easier to do post-filtering. If it is textual output, then you can ask another LLM, perhaps even to give you a score. So let's say on a range between 0 and 10, how much bad language is used there, or how much inappropriate topics are discussed there, something like this.
I'm still not convinced with regards to the system blocking it, but maybe later you can explain that.
Mm-hmm. Sure.
There was a question.
That was my question.
Yeah, that was your question. Then I go over to this side.
It was my question as well. Because testing,
Are you sure you will have a new question?
I have the same question as well now. Okay, so my question is this. So I just looked it up and you can put the system prompt in the backend, as far as I understand.
Yeah.
So you do not need to disclose it, which might make sense because we are all very proud of our fantastic prompts.
Mm-hmm.
But I was wondering about the tool calling, but because this way, can you do it also just in the backend? Because I assume some tools obviously need the front end to display something, or.
Mm-hmm.
But for some, you might want to query data in the database.
Yeah.
And getting the client in the loop unnecessarily, it's a bit overhead. Too much information disclosure, even there might be information you want to give the LLM that you don't want to give the user.
Yeah. Totally.
So I was wondering how this could be implemented with this hash prompt.
Mm-hmm. Yeah, good question. So what's when I want to have a server-side only tool call, something I don't want to expose? And the answer is, currently this is not possible. Currently, Hashbrown is just running on the client side. when we ignore this little tiny layer on the server side we need. But in the future, and I'm really in contact with them, they are thinking about connecting it to a server-side agent. And then the server-side agent can decide what to stream downwards and where to wait for an answer that comes from the client and what just to do on the server side. Perhaps one important thing here when it comes to this mode, this client-side only mode, is in terms of security, you are in the user context. That means your tools can only do stuff your user is allowed to do. This does not mean that we are completely secure, but it's at least a big gain. We can only do stuff the user is allowed to do. Besides this, of course, if the LLM runs havoc, it might do tool calling that is harmful for you. Deletes the entire internet or deletes something that's important. Perhaps it has good intentions. It says, hey, you need more time for your family, and so it deletes my next flight, something like this. And for this, we need some further guardrails, like categorizing tool calls into something that is always safe, like reading, stuff like this. Stuff that needs the approval from the user, and this approval needs to be outside of the LLM because we cannot fully trust it. And the third thing is things that are really dangerous. And when it comes to things that are really dangerous, it might be a good idea to just have a pseudo tool that tells you, oh, I cannot delete your user account, but if you really want, go to this menu item here and click there and do it by yourself. Something like this. But in general, and it's important here, with this mode, we run in the security context of the user.
Sure. Follow-up question to this one, to the tool calling.
Sorry, no follow-up question. One follow-up.
Okay, so I was following this because the first thing that came to mind for me was when generating JavaScript from the LLM was like, for a question like this, it would be interesting to generate an OData query, for example, fetch data, where we are too lazy or don't want to implement the user interface for it, and maybe not even the table that displays it. So now I wonder, could I use this to generate whatever is needed to display, for example, a prime and G table with that data OData queries? That's something that I should handle in another tool, or is it something I could fully do the thing?
Yeah, so this can be done with tool calling and structured output. So at the end of the day, we have a catalog with components, like perhaps a data grid, a fully blown one, or perhaps just a simple table or a layout container. And then the LLM can decide how to combine those components from the catalog to answer the question. Of course, it's always the question about how generic do I have to be. I always say be as generic as you need, but not more generic, because you might end up with a lot of troubles. But yeah, this is one of the solid use cases for this.
Next. Thank you for showing us this inspiring demonstration. I've seen, or nowadays, my question is about UI, where UI might go, because there's this simple ChatGPT, just one text.
Yeah.
With Codex, there's just CLI, so you're working just on the console. You now show a mixed version, which is like half automated, or you can click for yourself through. Are you aware of any studies, or what's your best guess where it could go?
Yeah, so interestingly, I'm discussing this with some people for 2 years now, and the last discussion was last week. And there we came to a nice conclusion. Like in the previous years, we had sentences like, it looks like we are moving towards this, and on top of how I understand the market, how I understand my customers, it will go into this direction. Since about half a year, we can really emphasize this feeling with some developments on the market, some standards that evolved for exactly like this, which show that a lot of companies are behind this. But also, meanwhile, we have some terms for this, last year we had to describe everything with a lot of sentences. It was really a difficult discussion. Meanwhile, I can say, let's do agentic AI. And meanwhile, we know what agentic AI means. Back then, it was at best one of the candidate terms with a lot of different meanings. Meanwhile, it's an established pattern. Also for a lot of other user interface patterns, like accepting a tool call, there are patterns out there, names and implementation strategies. So yeah, meanwhile, we are there where engineering starts.
If I understood it correctly, in the last example, you inject functions into the runtime?
Yeah, so if you think, if you think about the JavaScript runtime, it's a black box for you. Internally, it can execute JavaScript code without side effects, but you can inject, as you say, functions that then appear in the global namespace in there. And this is a way to phone out, to communicate.
Special runtime that allows such an input, and I just put in JavaScript code.
Yeah, and only the code I'm allowing.
Thank you very much.
Good question. Here's the next one.
I was thinking about the components and the life cycle of the components. If I tell your agent, hey, can you update the diagram, would the whole diagram disappear and a new one appears in the DOM, or will the existing one be updated, or how does the state of the data look like?
So as far as I understand the implementation of hash brown, I have not looked it up, but as far as I understand it, it's currently re-rendered, because you see it here, it's a chat and new messages come in, and sometimes one of those messages are a component. So technically, it's done that way. And behind this, we have something like an ng component outlet with some input bindings. And I don't think they are watching the bindings and updating them. I think they are just re-rendering everything. But this is an interesting stuff, so we should look into it and talk to the hash brown team.
Because it could be dangerous if you render input fields dynamically, the user enters something, and then the agent decides to update the UI and the user input.
Might be an issue, yeah. Perhaps not that much in a chat environment, but it's a real working area.
I think it's also something that frameworks themselves need to look at and provide the correct APIs. I mean, new types of APIs that we haven't seen yet for libraries like Hashburn to use and to build on top of this, so that it can leverage like some state that is known by the framework, but that is so they can reuse and not destroy it like every time we get to an info. Don't have much more to add about this. It's an interesting topic and really.
And I think the Angular team is looking a bit into this use case as well. Cool.
Not me.
Can we get, are you sure?
No.
Small one, plus more?
Very. I promise.
I give you 10 seconds. You get 5:20 more.
So, can I actually ask the chat like what tools are available, and like say that yes, you know that these kind of tools are available? Can I just misuse it in a way that are holding them?
It will not tell you. It will not tell you.
The standardization which stops it telling you?
I think by default it does not give you those internals. Because
I'm saying that if you don't download my grandma's into
yeah, if I want it to tell you, I can tell it in the system prompt. You are a friendly assistant, inform the user about this and that when they ask.
I mean, we could try it in the SAMP application to see if we get the tool calls out of it.
Yeah, and then hack it. Then, yeah.
Funnily, I tried that 2 days ago in the Hero IDE, and it did, like, you could realize, okay, there are tools available, or there are things available, and it says like, okay, I cannot tell you, but okay, there is something available after 10 times asking, but it did not give us any real, would say, access to the thing that it is having.
The formal description, like the JSON schema that describes tools and parameters.
Okay, can we get a massive round of applause for the talk?
Thank you.